Okay, question I. Let a be c greater than 0 and a is not 1. This bulky equation, which I CBA to read, of course, has a repeated root when which of the following happens. Okay, so this equation looks horrendous, but actually, if you look at the first term, there's already some massive simplification going on, isn't there? So this guy, like if you look at the inside, right, this is just b of x times x, yeah? So it's b of x squared. Careful, the x squared should be in brackets, yeah? So log b, b of x squared. So this is just x squared, isn't it? Yeah, because the log b and the exponential b cancels. Yeah? So if you don't write the brackets on top, normally, like for example this, right? If you don't write the brackets on top, it's assumed that it's this. Yeah, so I mean just be clear. Yeah, so I wrote b to the brackets x squared. Be careful. Okay, so that's just x squared, fine. How about next guy? So next guy, you can also take the x out, right? By log rules. It's x times log a c over b, right? Because this guy inside is c over b all to the x, yeah? So you pull the x power, in front. Plus, last guy, log a 1 over b, log a c equals 0. Okay, this looks a bit bad still, right? But we can use some log rules and it goes very nice. So x squared plus x times log a c minus log a b, right? Because it's division, yeah? So you use your log rules. And here, 1 over b, how do I change it to just b? Well, minus, right? Because 1 over b is just b to the power negative 1, and negative 1 comes down, so you know what you're doing. Log a b, log a c equals 0. Okay, so what on earth am I doing with this quadratic? The nice thing is that this is just a sum of roots, product of roots situation. Yeah, sum of roots, product of roots. So this is sort of a further maths thing. So it's a bit mean for them to, chuck it in here, but it's the MAT, right? So you've got to be good. Okay. So why is this sum of roots, product of roots? Because the two roots are, you can now see, the two roots are log a c, well, negative log a c, sorry, and log a b. Yeah. So the sum of roots is the coefficient of b, right? The negative of the sum of roots. Yeah. The negative of the sum of roots is the b coefficient. Yeah. The c, the constant, yeah, is the product of roots. Yeah. So if you multiply these two things, you do get the constant term back there. Yeah. So this is a sum of roots, product of roots situation. So you could easily factorize quadratics. Yeah. I mean, it's applicable in lots of scenarios, yeah, not only in this one. Okay, so the roots are those, and you want to repeat the root. You want to repeat the root, so you equate them. So log a c equals log a b. Good. Okay, now what happens? Well, the negative goes inside. Yeah, the negative goes inside. So this is log a of c minus 1 equals log a of b. And of course log a cancels nicely because a is probably some restriction on a there is. Yeah, a is not 1, okay, so you could cancel. So b equals c to minus 1. Yeah, so c to minus 1, my pen doesn't want to behave. You get the idea. Yeah, c to minus 1 equals b. I'm using my finger now, so. Okay, so I mean, then from there, you know what the answer is, which is option D, yeah? C equals 1 over b. So there you are. Wow, I tried to fix my pen.